Hi there, welcome to my channel Mathusism. Today I'm going to show you how to find these three trigonometric limits by basic tools only. This is the second episode of the series. In the previous one, we've gone through the following limits of sine, cosine, and tangent. You may check out the link of that video in the description. The link will also be in this video when we have to use those results. But now the question is, why are the limits written in this way? Let's start with secant x first. The Taylor series expansion of secant x about x equals 0 is the following. Subtract 1 to the other side and take out the common factor x squared on right hand side, we get this expression. Divide x squared to the other side and have the following. So that's explained the first limit of secant x. However, cosecant x and cotangent x are undefined at x equals 0. So we can't do the same thing on these two functions. Instead, we can make use of the Laurent series. To make it simple, Laurent series is similar to Taylor series, but it also includes negative powers of x. Therefore, even a function is undefined at x equals 0, we can still find its Laurent series. Now, the series of cosecant x and cotangent x are the following. You can see the term 1 over x for both series. For a non-zero limit, we consider squaring both cosecant x and cotangent x. That's pretty much about the origin of these two limits. Now, let's check out how to solve the problem. First of all, we work on the limits of secant x. We change secant x to 1 over cosine x. So it is equal to limit x tends to 0 1 over cosine x minus 1 all over x squared. Multiply both numerator and denominator by cosine x. Then we get limit x tends to 0, 1 minus cosine x over x squared times 1 over cosine x. The first fraction is very similar to the result we worked out in the previous video. They differ by a negative sign only. So the next step is obviously limit x tends to 0 cosine x minus 1 over x squared multiply negative 1 over cosine x. So it is equal to negative 1 over 2 times negative 1 over cosine. We put x equals to 0. So the final answer is 1 over 2. Now, we're going to work out the most challenging one out of the three limits. To start with, we change cosecant x to 1 over sine x. So it is equal to limit x tends to 0, 1 over x squared minus 1 over sine squared x. Next, combine the two fractions together, then it is equal to limit x tends to 0, sine squared x minus x squared over x squared sine squared x. As the numerator is the difference of two squares, so we can factorize it into sine x minus x times sine x plus x. Therefore, it is equal to limit x tends to 0, sine x minus x times sine x plus x all over x squared times sine squared x. Refer to the result in the previous video, limit x tends to 0, sine x minus x over x cubed is equal to negative 1 over 6. So we're going to take out these terms in the front. However, there's only x squared term rather than x cubed in the denominator. Therefore, we'll have to multiply an extra x in the numerator. In other words, it is equal to limit x tends to 0, sine x minus x over x cubed times x times sine x plus x over sine square x. Now, separate the sine square x term into two. We write it in this way. Limit x tends to 0, sine x minus x over x cubed times the second bracket x over sine x, and the last bracket sine x plus x over another sine x. Furthermore, separate the two terms in the last bracket, then we get limit x tends to 0. The first and the second brackets are unchanged, while we'll change the form of the last bracket into the following, which is bracket 1 plus x over sine x. Note that limit x tends to 0, x over sine x is equal to 1. So the final answer is equal to negative 1 over 6 times 1 times 1 plus 1, which is negative 1 over 3. Now we come to the easiest one. Using the identity cosecant square x equals to 1 plus cotangent square x, then it is equal to limit x tends to 0, 1 over x squared minus bracket cosecant square x minus 1. We group the first two terms together, so it is equal to limit x tends to 0, 1 over x squared minus cosecant square x, and then plus 1. And use the limits of cosecant x we just obtained, so it is equal to negative 1 over 3 plus 1, which is equal to 2 over 3. Ultimately, the limits of all 6 trigonometric functions are completed. If you'd like to watch more interesting math videos in my channel, please hit the subscribe button, like my videos, and turn on the notification. I'm happy to see your views in the comment section below. I'll see you next time. Bye!